Hi grade 11s and welcome to your first flipped classroom video. So hopefully you guys have your note sheet in front of you, but just in case you don't and you've somehow misplaced it from the time that it was handed to you in class to the time that you were sitting down and watching this video, never fear because you'll find the copy of the notes directly below this video on my website. So I want to start off this lesson by telling a little story. So let's imagine that you've gotten your N and you're out for your very first drive in your newish old car, your '82 Chevy Chevette, and it's a stormy day. And as you're driving, unbeknownst to you, you go through a radar trap and you get pulled over. Now the cop tells you that you're going 59 in a 50 zone. So I want you to pause this video for a second. I want you to think, is this measurement certain? If it's certain, why? And if it's not, why not? How is it measured? And what is the error rate? So what you might come up with is that maybe there's some obvious inaccuracies with the actual radar gun itself. Could be that there could be some interference from the storm or from the clouds. It could be that they may have gotten another car right behind you or in front of you. So it's important to note that in any instrument that we use, we have to be careful with our accuracy of our measurement, because no matter what we use, machines and our own senses are prone to inaccuracies and uncertainties. So where does this uncertainty come from? So this is what I want to talk about today, this uncertainty and how we can see it, how we can measure it, and what we're really looking for when we're making measurements. So whenever a measurement is made, there's always going to be uncertainty, and that uncertainty is going to be in the last place of the decimal. So usually the last value of a measurement that's given is usually that digit that is the uncertain digit. So this uncertainty is due to the facts that, well, one, measuring instruments, whether it's the radar gun that's measuring a speed, or a calculator that's performing an operation, or the scale that's telling you your weight, measuring instruments are never completely free of their flaws. No matter how advanced technology gets, machines and measuring instruments are always still going to have their flaws. Number two is that measuring with our own senses always involves some sort of estimation. And even measuring with tools still forces us to do some estimation. So for example, let's take a look at this pencil right below here, and let's say we're measuring the length of this pencil. So we can tell right from here that this pencil is at least 8 centimeters because it's pretty clearly over that 8 centimeter mark. Now it's not quite 9, so we can say with certainty that this pencil is 8 centimeters and a bit. Now if we look even closer, you'll note that the tip of this pencil falls somewhere between this 2/10 and this 3/10 mark there. So we know it's not quite 3/10, so we can say that with some certainty that this pencil is 8.2. After that, this is where estimation comes in, and this is where terms like accuracy and precision with our measurements has an effect. So this is really where that uncertainty comes in. If I were to give this pencil another digit of its measurement, I might say that this is halfway between this 2/10 and this 3/10. I might call this 8.25 centimeters. So with this measurement, 8.2 we can say because we saw with that piece of measuring equipment we found, or that we've been using, that 8.2 is pretty accurate in terms of, or reliable in terms of what we actually could see without using our senses. That 5/10 that happened at the end of that measurement, so 0.05, that is our estimated value. So 8.2 we are certain about, but that last place in that decimal, that's where we kind of made that estimation, and that is our estimated value. We're going to talk a little bit in our next lesson about where that estimated value comes in and the significance of the other digits. But for now, what I want to talk about is some terms I've been using sort of interchangeably throughout this video, and that is on accuracy and precision. So I just want to talk about these two terms before we move on to our next unit here. So when we're talking about accuracy, we're talking about testing a measurement and testing it against a standard. And by a standard, I mean a true or expected value that you expect for that measurement. And if it is close to that expected value, so if that measurement you make is close to that expected value, then we can say it's accurate. So let's take a look at an example here. Let's say you are on your calculator and you're doing an equation like 10 minus 8. So 10 minus 8, what we'd say the standard would be, what you would expect would be that you would get an answer of 2. So you're expecting that you're going to come up with 2. Let's say you plug it into your calculator, 10 minus 8, and for some weird reason, it comes up with 5.4. So you wouldn't say that this calculator is very accurate because this is far away from that standard. 5.4 is far away from that expected value that you're supposed to have. So you try it again. You get 10 minus 8. And this time when you plug it into your calculator, you come up with 3. So this value is a little bit better. It's not the correct answer and it's not closest, it's not our expected value. But we can say it's more accurate than that first measurement because it is closer to that expected value. Let's say you type it in again, 10 minus 8, and you come up with 2.12. It is more accurate because it is closer to that expected value. It is not right on that expected value, but we can say it's more accurate than our prior measurements. So that's what accuracy is. How close your measurement is to its expected value or its standard value. We're talking about precision, and ultimately these terms are kind of used interchangeably, but they are different. When we talk about precision, we're talking about when you're taking measurements and you get the same results over and over and over again. So you get the same results over and over and over again. So let's take a look at this calculator example again. And let's say you're typing in 10 minus 8. And this time you get 7. So once again, far from that standard expected value of 2, you get 7. So you try to type it in again, and you type it in again, you get 10 minus 8, and you come up with 7 again. And you do it again, and you get 7 again. It could be something is wrong with your calculator, it could be something is glitching, it could be on some sort of weird mode, that every time you type in 10 minus 8, you're getting 7. Now, like we said, these results aren't accurate. But the more times that we take this measurement and we get 7s, well, the more precise we're being in our measurement because we're actually getting the same result over and over and over again. So there's repeatability with that result. 7, 7, 7, 7. Even though it's not accurate, it is precise because we keep getting the same result over and over and over again. So what does that have to do with measurement, and what does that have to do with what we'll be learning about in class? Well, one thing I want to drive, the very point I want to drive home here, is that if we're going to have a reliable measurement, if you're going to use an instrument that's going to help us measure lab value or some sort of result that we're trying to get, it's important that our measurements should have high accuracy, meaning that the values that we obtain from our measurements are close to our expected value, and also high precision. So that would mean if we typed it into our calculator again, 10 minus 8 equals 2, that we would say is accurate, and the more that we did it, got 2 times equals 2 equals 2 equals 2, the more precise our measurement is. So high accuracy with high precision leads to measurements that have fairly low uncertainty. So I want to thank you guys for watching. I encourage you guys to try those practice questions below, and if there's any questions that you guys had in regards to this video, please leave that in that question section on your notes, and I'm looking forward to discussing this next time in class. Thanks for watching.